Hello, in this video I will introduce you to the new Miniature Confocal controllers from Micro-Epsilon. The development of confocal technology continues at pace with the introduction of our next confocal controller, the IFD2411. This new compact controller design maintains all of the key features of confocal measurement but is a third of the size of a standard controller and can save valuable space in the control cabinet. The newly developed IFS2404 confocal sensor is bundled with the controller and is available with either a 1, 2, 3 or 6mm measurement range. It is possible to have up to 10 sensors calibrated to an IFD2411 controller, but only one can be used at a time. One of the key advantages of confocal technology is its ability to measure on any surface, including highly polished and even transparent materials. Despite its compact size, the new controller is still capable of displacement and distance measurements and is also suitable for single-sided thickness measurement of transparent materials. The controller features an adjustable measuring rate of up to 8 kHz and sub-micrometer resolution down to 12 nanometers. When coupled with the IFS2404-1 sensor, the measurement linearity is better than plus or minus 0.5 micron. The active exposure regulation of the CCD line enables high-speed measurements on difficult changing surfaces, making the IFD2411 suitable for a wide range of measurement tasks. The confocal controller is now even smarter due to its integrated industrial Ethernet interface, which currently is EtherCAT, and this simplifies integration with PLCs. This enables real-time measurement data without time delays and reduced installation effort. Ethernet IP and Profinet versions will also soon be available. Data can also be output via analog and serial RS422. The IFD2411 is delivered as a system with the paired sensor. Terminals are available directly on the controller for power connection of a 24-volt DC supply, as well as trigger and or synchronization signals. The RJ45 port allows direct connection to the industrial Ethernet environment. In addition, you will need to specify the length of the fibre optic cable, which can be up to 50 meters. And if necessary, purchase the optional SC2415 OE cable for access to the analog and RS422 output and an additional encoder input. On the controller, there is one push button called the multifunction button, which can be used to instigate dart referencing, a return to factory default settings, or adjustment of the boot mode from EtherCAT to Ethernet. So let us now take a look at how we get the system set up and measuring. LED indicators show quickly if the system is measuring correctly and any communication state. If you want to check the target is in range of the sensor before opening the software, you can do this by looking at the range indicator on the controller itself. Green indicates that you are in range, amber is the centre of the range, and red is outside of the range. I already mentioned that the default interface is EtherCAT on this controller, and if you are using EtherCAT, you can go right ahead and connect the sensor to your EtherCAT network and use SDOs, service data objects, to get information from the controller and make setting changes. I don't have an EtherCAT network available here, so I can either change the controller to Ethernet mode using the multifunction button on the controller, or I can use the RS422 serial interface via the optional cable to access the system. I will put the button procedure up on screen for those wanting to use Ethernet communication for setup. To use the button procedure, first turn off the sensor. Then, whilst pressing the button on the controller, turn the power back on. When the intensity light is flashing yellow, release the button. Then press and hold the button for 10 seconds. When the intensity light starts to flash yellow, release the button. The controller will now switch from EtherCAT mode to Ethernet, which takes up to 1 minute. You can now access the web interface by connecting the sensor to your LAN port and entering the IP address in your web browser. The factory default address is 169.254.168.150. If you have access to a Micro-Epsilon IF2411 USB interface or IC2001 USB cable, or an alternative RS422 to USB adapter, you can also access the settings via the serial interface using the optional SC2415/OE cable. The wiring is shown on screen for you now. The graphical user interface, or GUI, should look familiar to previous users of the confocal systems from Micro-Epsilon, as well as any other users of our laser triangulation sensors. If necessary, change the language to English. On the web interface, you will have the main measurement screen with tabs across the top area and measurement parameters down the left-hand side. Depending on the tab you are in, these menus will change. The purpose of the web interface is to allow configuration of the controller settings. The main screen is showing the current measured value, and you can select between the measurement chart or the confocal video signal, which shows the peak signal return from the target surface. If you have multiple peaks, that would indicate you are measuring against a transparent target, possibly with several layers. The IFD2411 controller is capable of single-sided thickness measurement, and there is no multi-layer option. For simple measurement tasks, you can use the measurement configuration and choose between the type of surface you are trying to measure. For single-sided thickness measurement, choose the one-sided thickness. The settings are adjusted, so we now see the distance for the first peak, the second peak, and the overall thickness calculation. If we look at the video signal, we can now see that both peaks have been detected. The signal quality slider is used to adjust averaging on the controller. And the system configuration settings just shows you the current settings that have been applied inside the controller. To make controller changes, we go to the Settings tab. The first setting is that of the sensor. I mentioned previously that the IFD2411 can have up to 10 heads calibrated to the controller. If you have multiple heads, you must ensure that you have selected the correct calibration from the sensor setting. Dark reference should be performed each time you connect a new sensor to the controller. The process takes about 20 seconds. With inputs, you can determine whether controllers are being synchronized, whether encoder input signals will be used, define the input signal level as either TTL or HTL, and if the controller is part of a master-slave arrangement, set the terminating resistor on it if it is the last unit. With data acquisition, you can control the measuring rate, activate trigger settings, adjust exposure, and set the number of peaks expected, including which peaks you want to measure. If you are measuring material thickness from one side, be sure to set the material type and/or adjust the refractive index in the material table. A selection of common transparent materials is already stored. In signal processing, you can build calculation blocks to apply averaging to a signal or combine readings together for thickness. Post-processing provides options for zeroing or mastering data, as well as output triggering, statistics on the captured measurement, data reduction, and error handling if targets go out of range. The output section allows you to select the signals to be transmitted from the controller on the various interfaces available. Finally, in system settings, you have control over how you display the measured data. You can import and export settings, as well as reset the controller back to factory defaults. Most importantly, you are able to select the boot mode to be either EtherCAT or Ethernet. If you have made settings changes, please ensure that you use the Save Settings button to save those into the controller for the next startup. So there you have the new compact IFD2411 miniature confocal system from Micro-Epsilon. The addition of the IFD2411 along with the new all-in-one IFD2415 system perfectly complements our existing twin-channel confocal controllers, and with sensors offering measuring ranges from 100 micron up to 30 millimeters, we're sure to have a confocal measuring solution for you. For more information and to download a datasheet, please visit our website at micro-epsilon.co.uk. If you'd like a demonstration or wish to discuss an application for this or any of our sensing ranges, then please send us an email to info@micro-epsilon.co.uk. For international inquiries, please check our worldwide contacts via our website. Thank you.